In this video, I'm going to talk about a nice trick of expanding a logarithm of 1 plus x using the binomial expansion that I just showed in the previous video. Let me write it first. So, log of 1 plus x. Series expansion. Okay. So log, what I mean by log is logarithm, natural logarithm. So I would like to find out what logarithm of 1 plus x is. So I'm going to start by noting that this is actually the integral. This is equal to the integral of dx divided by 1 plus x, right? And then the reason why I'm doing that is because it will be clear in a moment. I would like to use the binomial expansion of 1 over 1 plus x in here, and I will show you that it actually leads to a nice expression for this logarithm term. So remember that 1 over 1 plus x is equal to, so in series notation, from n is equal to 0 to infinity, that was equal to minus 1 to power n times x to power n, right? That was the binomial expansion, which I showed in the previous video. So this is equal to, so this integral actually is dx times the series, right? So instead of 1 over 1 plus x, I'm writing in terms of the binomial expansion. So now I can actually integrate this. So if I push this integral through, that will be n is equal to 0 to infinity minus 1 to n, because that doesn't depend on x. I have dx times x to power n. But this is nothing but x to the n plus 1 divided by n plus 1, right? So this whole expression of logarithm of 1 plus x becomes the series expansion from n is equal to 0 to infinity minus 1 to n times x to the n plus 1 divided by n plus 1. So using this binomial expansion and realizing that this logarithm is equal to this integral, you can actually have this. This is going to be useful in the integral that we saw on previous chapters on Gauss's law, which was Q total for a non-uniform charge density. And I'm going to show you that using this expansion, you can really get get exactly the same thing that we did in the previous case. And if this series notation confuses you, let me, if you like, write this in terms of the polynomials of x, and then it might be clearer. So dx, 1 over 1 plus x is this, which is actually, the first term is going to be 0th power of that, and which is 1, and this is also 1. And the second term, n is equal to 1 term, gives you minus from here and x from here, and it goes like alternating, right? Etc. So what I'm trying to do is I'm trying to write it in terms of like this, which is sometimes less confusing for some people. And I'm going to show you that this is actually equal to that, okay? This works, but seeing that explicitly sometimes helps. Okay, so the first one gives you dx times 1, the integral, so this one gives you just x. The second integral is minus x dx, which is minus x squared divided by 2. And the third term gives you dx x squared, which is x cubed divided by 3, and x to the 4, this term divided by 4, etc. So you see how it goes, and if I write it here, you will see that it's exactly this thing, right? So you see, if I write the first term in here, n is equal to 0 term give you, from here it's 1, and this gives you x to the power 1 divided by 1. And this is n is equal to 0 term. The next term, n is equal to 1 term, gives you minus 1 to the 1, which is minus 1. And this is going to be n is equal to 1, so that's why it's x to the 2 divided by 2, right? And you can infer the rest, right? So you see that both of these things are exactly the same. So this is a nice trick for expressing logarithm of 1 plus x in powers of x.